Here we are learning how to do derivatives using the product rule and the quotient rule. So when you have a product or a quotient, what you can't do, you can't take the derivative of each one separately and multiply them together. You can't take the derivative of the top and bottom separately and divide those two things. That's not going to work. Think about why that doesn't make sense. Anyways, if you did the derivative of each one separately, you got 7 and 2, and you got 14 for the derivative, you're saying the slope of this quadratic is always 14. And you know the slope of that quadratic changes depending upon where you're at because it's a curve and the slope isn't always the same. So it makes sense that the derivative should have a variable attached to it. So these are still shortcuts. We're not using that main definition, but they're a little bit longer shortcuts than that power rule. Let's start with the product rule first, right? You've got to have this memorized. You're going to do first times the derivative of the second plus the second times the derivative of the first. This is the same thing, just in notation form. The AP test will give us problems with the notation. We'll have to do some of this in the homework, where when you're given a function with the notation, this is the same thing as above. That's your first function, times it by the derivative of the second, plus that second function, times it by the derivative of the first there. So homework-wise and AP test-wise, sometimes you got to take the derivative first with the notation and then plug in items. You know, sometimes they'll give us the graph to figure out a certain slope. Sometimes they'll give us a table, or they'll just give us everything that we need there. All right, so product rule. This one you can multiply all out first and then take the derivative, but in the future we won't always have that option because sometimes you might have like a 14 as an exponent there, a 7 as an exponent right there, and when you do that, also right here, if you just have sine times cosine, you have to use a product rule. You don't have an option of just like multiplying it out like you do this one. So there's definitely times where we need to use the product rule. Okay, so let's apply this to this basic problem here. So we're going to go first function, just write it down. Then you're going to times it by the derivative of the second. So the derivative of 2x plus 4 is just 2. And then you're going to go plus. You're going to do the second function, just write it down. And then you're going to times it by the derivative of the first, the derivative of that first, which is just 7. Now, when you're doing the product rule and the quotient rule, I'm going to tell you, if it looks simple, multiply it all out, distribute, combine like terms. If it looks crazy and it looks complicated, you got to think factor and you got to think GCF because multiplying it out is only going to make it worse. So this one looks pretty easy. Let's just distribute this real quick. They're going to get 14x minus 2 plus 14x plus 28. And then that's going to give us 28x plus 26. If we could do a GCF with variables, we're going to do that. If it's a GCF with just the numbers, you can do the GCF if you want, but you don't have to. So for example, if you get like 4x to the 5th plus 3x to the 7th, you know, if you can do a GCF with the variables, then you must do that. So if you got to pull out the x to the 5th, and you'll be left with the 4 plus 3x squared. All right, so if it's a GCF that can be done with the variables, we got to do that. That's going to help us out in the next chapter when we start applying derivatives, and it's already going to be simplified for us, okay? But if it's just the number part, you can factor it out or GCF, or you can just leave that alone. It doesn't matter. All right, let's do another example. You're multiplying two functions together, so that means we're going to do the product. You don't just do the derivative of this one, which is cosine, and the derivative of that one, which is a negative sign, and multiply those together. You have to apply the product rule because that's a product right there. So we're going to go first function, just write it down. We'll times it by the derivative of the second function. The derivative of cosine is a negative sign. And then you'll go plus the second function, just write it down. And then you'll times it by the derivative of the first, and then we're supposed to know the derivative sign is going to be cosine. And again, what's in this section, what we did in a prior section, that's the list of all of your trig derivatives right there. I think the prior section just did the first couple. This section is going to involve all 6 of those. So we got to make sure we know all of those. And again, brush those teeth. And then you should simplify this. We can make this negative sine squared x plus cosine squared x. And then you're allowed to stop right there. Now the book might, the answers in the back of the book might make that cosine squared minus sine squared. They might turn that into the double angle formula like the cosine of 2x. You don't need to do any of that right now. You can just stop right there. So just practice your product rule. If it looks easy, multiply it all out. If it looks complicated, we want to go ahead and factor that. All right, quotient rule. Similar concept, right? But you're going to start with the fraction, all right? And here you got to have this memorized. You're going to go denominator times it by the derivative of the numerator minus your numerator times it by the derivative of the denominator all over the denominator squared. This is the same thing, just in notation form. So if you have a fraction, when you got to do the derivative of that fraction, you're going to rewrite the denominator times it by the derivative of the numerator minus that numerator times it by the derivative of the denominator all over the denominator squared. So the order doesn't matter on the product rule because there's a plus right there, but the order matters on the quotient rule. So if you switch these around, that's a pretty significant deduction because you don't know your quotient rule. But a common mistake is people started with the numerator, always started with the bottom, all right? Started with the denominator and then just go through that. Also, from the prior section, if I take this +2 away and you have a monomial in that denominator, the quotient rule will work, but it's unnecessary and it's a longer problem, okay? So if you have a monomial, remember what we learned in the prior shortcut, is you could do a that over that, that over that, that over that problem. But once you put that binomial right there, then you can't break this up. You just have to do the quotient rule straight up now. So let's apply the quotient rule. So we're gonna go denominator, write it down, and then you'll times it by the derivative of the numerator, which is your easy 2x minus 5. And then we're gonna go minus the numerator, write it down. And then you'll times that by the derivative of the denominator, which is just 1. And it's all over that denominator squared. Now in a testing situation, I would make sure I get that down. Sometimes people ignore this, simplify all the other stuff first, and then sometimes they forget to bring back in that denominator squares. If you don't have it there, that's a big deduction because your derivative is not there. It's wrong. You have calculus stuff is just wrong. Now, the denominator, you pretty much leave alone. Sometimes you might be able to factor and cancel something on the top, which might cross something out in that denominator. But most of the time you leave the denominator alone and you just go and simplify the numerator, all right? And same thing, if it looks simple, like this one hopefully does to you, multiply it all out, distribute, combine like terms. If it looks complicated, like it's about to do on the last one we're gonna do, then you're gonna think factoring, okay? So if I multiply this out, I'm gonna do this right above there. So that's gonna give us a 2x squared. You're gonna get minus 5x plus 4x, which is a minus 1x. And then you're gonna get a minus 10. And I'm gonna distribute the negative through. And now I'm gonna combine like terms. So 2 minus 1, you're gonna get 1x squared. You got negative 1 plus 5x, it's gonna give us a 4x. And then negative 10 minus 3 is gonna give us a negative 13. Carry down your denominator. And then there is our first derivative. If you had to do a second derivative, guess what? You got to do another quotient rule with that stuff right there. And with those higher exponents, we're going to learn how to handle some of that stuff in the future there. If you can factor that, go ahead and do so. But a lot of times you're just kind of done right there. And again, if you can do any sort of GCF with the variables, make sure you pull those out because it's going to be nice if we practice that now. When we get to the next chapter, we're already going to have that done. And then when we apply it, when we take derivatives, when we find maxes and mins, and we need to set the top and the bottom and set stuff equal to 0, it's already going to be in a nice version for us. Because if you try to simplify this, it's a mess. But if you just set this equal to 0, okay, I can do the quadratic formula. If I set this equal to 0, I'm going to get an easy x equals -2. If I set this equal to 0, it's going to be easy to simplify or easy to solve things when you have them simplified properly. All right, let's do one more problem, and then we're done here. This one, you could not do a that over that, that over that, because that's illegal algebra. If you had them reversed and you had the monomial in the denominator, then you can do that, okay? But you can't break up that denominator right there with the binomial. So one thing I am gonna do, when we do derivatives, the radicals like that don't ever help us. I always get rid of those and make those into the exponent form. And the first step of this is going to be pretty normal. We're just going to apply this quotient rule, and it's going to be pretty easy. And then what we'll do after that is a simplifying. That's where we're going to have most of our questions on and spend the most of the time doing there. All right, so when we do this derivative, we're going to go denominator. We're going to times it by the derivative of the numerator, which means we're going to multiply by the power, decrease that power by 1. Then we're going to go minus the numerator, write that down, times it by the derivative of the denominator, which is a 2x, all over the denominator squared. All right, so calculus is completely done. The calculus is typically not what we struggle with in this section. It's the simplifying, it's the factoring, and I'll have a separate factoring worksheet for us. It's going to be like an optional thing to do, but I strongly suggest that we practice that. I'll have the problems, I'll have my work and stuff on the back, and then we could always do a couple together if we need to. Now, this does not look as simple as this right here. This will also get worse. A lot of times we'll have binomials here, trinomials here. where factoring is the method that's always going to work here, okay? So I'm not going to multiply this stuff out. I'm going to think factoring. And so we just got to practice this, pay attention here, practice on your own, and then ask questions and we'll get good at it. First thing I can do, this is x to the first, which is 4 over 4. So I can take this and I can rewrite this as 2x to the 5 over 4. So it's like I'm not really looking at this right now. That's 2x to the 5 over 4 in that spot. All right, now a couple of tips as you're factoring. So ignore the denominator. We're just going to factor out on the top part there. If you have a fraction, you want to factor out the fractions. If you don't factor out the fraction, then you're going to have complex fractions in your final answer, and we're not allowed to have complex fractions in the final answer. You always have to get rid of complex fractions. Also, if I have a 3 over 4 right here, I'm not pulling out the 3/4, I'm just pulling out the 1/4. Just pull out the denominator part there. So I'm going to factor out a 1/4 and then the smallest exponent. So it's like if you have an x to the third and an x to the fifth, you're going to pull out an x to the third, right? So if you have an x to the negative 3/4, x to the 5/4, I'm allowed to factor out an x to the negative 3/4. That's the smaller of the two exponents. Now, if I had an x squared plus 1 to the 4th here and an x squared plus 1 to the 8th here, I'm allowed to factor out an x squared plus 1 to the 4th. But I don't have another x squared plus 1 factor, but just in the future you will. So this is the only thing I can pull out front. There's my GCF. And now we got to match up what we have on the inside. So as you compare this, you have two things that you're going to have in between that minus sign. So there's my minus sign carrying down. And now we got to match up this thing here with this times this is going to give us that. And then we're going to match up this box here. This times this is going to give us that. Just like when you have a normal GCF problem there. So as you compare from here to here, you already pulled out this stuff. That's already there. You're missing that. So you need an x squared plus 1, that thing there. Now, when you take this times this and you redistribute that, you have that whole entire green box. And then you got your minus sign. Now, right here is where you got to be careful. So if you go GCF, remember, like, let's say I pulled out a 2 right here. Then I would do 4 divided by 2. That would be a 2 right there, right? And so to get this number here, we got to take this number divided by this number. Now, if you go 2 divided by 1/4, remember 2 divided by 1/4 is the same thing as 2 times 4 over 1, which is going to give us an 8. And think about when you distribute 1/4 times 8, that's going to give us the 2. So we got that matched up. Only thing we got to work on now is what to put for that exponent right there. Now, when I take this times this, I would usually ask you, hey, what are you doing with these two exponents right there? When you take x to something times x to something, you are adding those exponents. So I got to be able to add up this exponent plus whatever's in that box. That's got to equal the 5/4. Now, eventually, you'll get so good at this where you won't need to do this. But at the beginning, when you're first trying these, it might help to do this. Like, come to the side, just go negative 3 over 4 plus whatever's in that box. That's got to equal that 5 over 4. And it helps me to think of it in terms of a common denominator. So then we know negative 3 plus 8 is going to give us that 5, and then 8 over 4, that's going to give us a 2 right there. Typically, when you do these, those exponents are typically nice integer numbers there. So it's almost always a 1, a 2, occasionally a 3, occasionally a 4, but it's usually just nice numbers like that. And then after you do a factoring step like that, 99.9% of the time, you're just about done. You just have to go inside those brackets, distribute if you have any parentheses, distribute and combine like terms. There's nothing to distribute here, but I can go 1 minus, I can make this 1 minus 7x squared on the top. And then remember, we're supposed to get rid of the negative exponent. So since there's no plus or minus right here, we're allowed to drop the 4 down to the bottom. We're allowed to drop that negative exponent down to the bottom. And then we are done. So we will get you, oh, my fault, almost done. So that's that stuff. And then you got to remember to carry down that original denominator squared. So we should have x squared plus 1 squared at the end. I usually like sometimes write that right here, and I just forgot there. So just make sure you're careful with that and get that whole thing down. Now in the future, if I say find a horizontal tangent line or a max or min, we're going to need to figure out where this derivative is equal to 0. And that's why we practice simplifying it, because when we apply the derivatives, if I ask you to take this nightmare and set that equal to 0, it's not impossible to solve, but you got to do all this work in order to solve it. See, we already have this down. Now, if I ask you to set this equal to 0, you move the 1 over, divide by the negative 7. You know, you're going to square root both sides, and it's easy to get the zeros for the top and the bottom when we have that simplified the right way. So we got to just keep practicing the simplifying on those. And again, don't leave the negative exponents in your answer. Typically, when we do the quotient rule, if you have stuff broken up, you want to try and get one single fraction like we got for both of these. So it's helpful to have the one single fraction. And then if it looked complicated, we just got to get better with that factoring on there. And again, if you need your trig derivatives, you're going to need your trig more in this section as well, with especially with these harder ones, they give us some of those. So make sure we got those down, and so we're automatic with it, because though the trig won't ever go away, and eventually we're going to do integrals, we're going to be going in reverse. So we got to make sure that these are really, really sharp in our head.